Can you solve a numerical without knowing the initial velocity or the acceleration? It sounds impossible, but that's exactly what this JEE 2002 question asks. A bullet loses half of its velocity after penetrating 3 centimeters into a wooden block. How much farther will it travel before coming to rest? If this question makes you wonder where to even begin, don't worry. In the next few minutes, I'll show you a simple trick that makes it surprisingly easy. Welcome to the Motion in a Straight Line numerical series. Before we begin solving the problem, let's first establish our sign convention. Any displacement, velocity, or acceleration directed towards the right will be considered positive. Anything directed towards the left will be considered negative. Now, we'll divide this problem into 2 simple steps. The first step is from the instant the bullet enters the wooden block until its velocity becomes half of its initial value. The second step is from that point until the bullet finally comes to rest. Before jumping into the solution, let's remove all the text from the screen and first understand what's happening to the bullet. The bullet enters the wooden block with an initial velocity, v1, moving towards the right. As soon as it enters the wooden block, it faces resistance from the wood to move forward. This resistance to motion results in a decrease in the bullet's velocity. And a decrease in velocity is nothing but acceleration in the opposite direction. Since we have taken the right side as positive, this acceleration will be negative. In other words, it is a deceleration. Let's start with the first step. First, let's write down the known information. Let the initial velocity of the bullet be v1. At the end of the first step, the velocity becomes v1 by 2. The bullet travels a distance of 3 centimeters during this interval. Converting it into SI units, we get a displacement of 0.03 meters. Now, if you haven't watched my video on choosing the correct equation of motion, I highly recommend watching it after this lesson. It explains a simple method to decide which equation to use in any numerical. In this problem, time is not given. However, we know the initial velocity, the final velocity, and the displacement. That immediately tells us that the third equation of motion is the most appropriate choice. Substituting the known values into the equation and simplifying, we obtain the expression for the acceleration. Notice that the acceleration comes out to be negative, exactly as expected, because it acts opposite to the direction of motion. In other words, it is a deceleration. At this stage, don't worry that we still don't know the value of the initial velocity, v1. That's perfectly fine. In the next step, you'll see that it cancels out completely, allowing us to find the answer without ever knowing its actual value. Now, let's move on to the second step. Notice that the acceleration remains the same throughout the motion. Since it is acting opposite to the direction of motion, it continues to be negative. For this step, the initial velocity is v1 by 2, the final velocity is 0, and the acceleration is minus 12.5 v1 squared. Our objective is to find the additional distance, s, traveled by the bullet before it comes to a complete stop. Once again, time is not involved in the given data, so the most suitable choice is the third equation of motion. Substituting the known values into the equation and simplifying, we obtain the required expression for the distance. Notice something interesting here. The initial velocity, v1, cancels out completely, exactly as we expected. This is why we never needed to know its actual value to solve the problem. We finally get s equal to 0.01 meters, or 1 centimeter. This means that after losing half of its velocity in the first 3 centimeters, the bullet travels only 1 more centimeter before coming to a complete halt. Therefore, the correct answer is option A, 1 centimeter. Thank you for watching this video. If you found it helpful, please like this video, share it with your friends, and subscribe to the channel for more animated physics lessons. In the next video, we'll solve this JEE level numerical step by step. Until then, keep learning and I'll see you in the next one.